Hello everyone, my name is Savik Mukherjee. I am a MS by research student in the COC department of IIT Kanpur. So, all about this presentation. This is a contest held by Altair and Techkriti of IIT Kanpur. This presentation is all about it. So, my subject in this presentation is impact of social media on health. So, I have collected a CSV file from Kaggle. I'll be showing it. So, these are all the attributes which are present in this CSV file. So okay, let me show you in this particular software, which is the rapid miner software, which is developed by the Altair. So this is a very good software to visualize data, make model, visualize the model outputs, and play with different kind of models, with very ease. So okay, so this is the CSV file which I was talking about. Its name is final.csv, which I have opened here in the results part of uh, the final CSV is compiled properly and it's opened over here. So let me talk about this CSV file. So we are having attributes like what is the age, gender, relationship status, occupation status, kind of organization the person is working in, uh, which kind of social media does the person use. This column is kind of opened here properly, which all, like suppose this person was using Facebook, so we have made a binary kind of response to it. Like if the person is using Facebook, so the value will be yes. If it's not using the Facebook, it will be no. Similarly for all other social media sites. So this ends the social media integration from the person. So after that we have certain kind of questions, like 12 questions are there which we have asked to the person to learn about the severity that this social media is causing, or in general the kind of health issues or health problems, like nominal health problems the person is facing, like things like how often does the person use social media without any purpose, or like how much distraction does a person have with social media, how much restless does the person feel. So these kind of questions are somehow not related to social media directly, but we can infer that might be using social media too much make the person feel restless too much. So the questions like this, like how distracted is the person. So all these 12 questions are collected in a scale of 1 to 5. So what I have done in the design part is, so this is the CSV file which I have just showed. So I have generated an average out of all the 12 questions which I was telling right now. So these 12 columns are having answers in the range of 0 to 5. So so I have averaged out all these responses. So this average kind of says that if the value of this average is more, the person is more likely getting too much distracted or having health related issues, specifically mental health related issues, by using social media sites like Facebook. So this is the first entity generating the average. After that I have selected certain attributes and removed certain attributes, like there was some useless attributes like do you use social media, and the question like what social media platform do you commonly use. This had all the aggregated values of social medias with the person you used. So I have made it separate. We have separated these outputs, like if the person was using Facebook and Instagram, so we have made it as a binary response to make Facebook and Instagram fun, and rest all will have it 0. So I have selected out all these required attributes over here, and after that I have set role of this average to be a regular. Now the problem is this average value which was coming is a real number. Now if I try to make a decision tree out of a real number, the decision tree will be very much spread out. So I don't want that thing. So what I want to do is I want to discretize this thing, that is make certain bins. So I have made uh, six bins to classify this 0 to 5. So how the bins look like is this: we have these bins, like the bin 1 is minus infinity to 1.667, then goes to 1.667 to 2.333. So instead of having all the real numbers, we have put all the values into this bin of numbers. so that the decision tree could be very nicely seen. So after making the bin, we have set role to make the average as the label for the decision tree, and then we have applied the decision tree to it. So in this design part, my experiment is having 4 results. One of them is decision tree, another is a deep learning, the next is naive bayes, and other one is polynomial regression. So what these sub processes are is this entire process which we are seeing from retrieval to set role has been put inside this sub process. So if I open this sub process, we can see this thing. So we are having all these things inside it. So let's we are having all these things. Now coming to deep learning models like deep learning models, and coming to problems like polynomial regression, we don't need the concept of bins over here. So these process don't have the discretization part inside it. So we are having just the normal the value and generating the average, selecting out the attributes that we need, and then setting the role to label and then using it. In contrast, in processes like naive bayes and decision tree, we are having the discretized value, that is the bins, so that we can see what is happening properly. So these are all the things. So I've added a comment to properly. So what are the 12 questions that we are averaging out and putting in this average attribute? So this is the CSV file. This is making of the average, and then we are selecting the required attributes, then changing the role to discretize the or make the bins, and then again changing the role to make it a level and put it into the decision tree. So now I'll run this process over here and see the results. So yeah, the results are generated, and here we can see them. So the polynomial regression is making out a formula. The formula is something like, we are having all the attributes and we want to find the answer of prediction of we want to find the prediction, that is like it's kind of a regression thing. So we will be putting values of gender, relationship status and all those things, and then we'll find the answer. And one more thing, in polynomial regression we need numeric values. So in case of polynomial regression, we have changed all the non-numeric values to numeric values, and then we have used the polynomial regression. So if we see here, we just need to put all the the numbers or the integer values inside this, like gender, relationship status, which have been changed, and we can see how those changes are happened over here. So once we put out all this value over here, we can find a answer. Now this answer is the prediction. So in case of the predictive model of polynomial regression, what we are having, the answer will be like a real number. So it is what we were having before converting into bins. Only the polynomial regression and the deep learning model will give the real number output, and rest all will not give real number output. So let me show you the results which we have generated. This was the polynomial regression, and now we have the naive bayes. So naive bayes is having one of the best distributions. We can see, like, if the age group of the person lies from 15 to 25, the red spikes are a bit higher. So what does this red spike means? So we can see this is the range. The red spikes belongs to the range 6, which is from 4.333 to infinite. So this means averaging out all those 12 questions, all the answers to the 12 questions were from 1 to 5. Now after averaging out all these questions, the answer for these people were 4.33. So this kind of is a red flag that might be worrying that these people are having all of these problems, like most of the problems in average value. They are having most of the problems. So this means if these red spikes are high, these persons are more likely to have health related issues because of social media size. So now this also shows for other attributes like gender, like occupation status, and different kind of organizations that they're working in. So if you see the organization status, the spikes are mostly there in university. Like this is it, we're having higher red spikes in universities, whereas in case of private companies, schools, government organizations, the red spikes are pretty much lower. So similarly, if we see for different kind of Facebook, different kind of social media handles, we can see how these distributions are changing over here. And this is the decision tree. This was the bins which were made, like range 5, range 1, the 6 bins which we were having. So this is the start of the tree, like if they are finding the age is less than 67, and then they're again classifying the age as less than 55 or more than 55. So this is kind of the decision tree which is being made, the amount of hours they are spending in social media. And like this, if we classify and see a branch, we can see how the tree has grown. So this is a decision tree, and this is similar to the deep learning model with all of the different kind of parameters which we can see over here. And so this was the basic design and the basic results of all these 4 parameters that we have seen: deep learning, naive Bayes, polynomial regression, and the decision tree. So apart from this, the platform also has a very beautiful way of solving the problem, that is using the auto model. So to use the auto model, I have created another CSV file. Like in the main CSV file, which is the final CSV file, we had all these attributes, and like this 12 attributes which we had these 12 attributes, and we made average out of them to in the design sector to see the decision tree and other things. So instead of doing that, I have created another CSV file in which the averaged value is pre-calculated, and it is put in this attribute, which is like impact of social media. So if you open this modified CSV using the Rapid Banner Studio, we can see different statistics and visualizations over here. So in the statistics, if you see, the minimum age of the person who took the survey was 13, the maximum was 91, the average was something around 26. There were around 263 females and 211 males. So also we can see people who are using Facebook are around 407, who are not using Facebook are around 74. So these are the kind of statistics we can see directly using this statistics tab. Now if you go to visualization, the impact of social media is in this x-axis. So if the severity crosses 3.5, we can say the social media is causing some health related issues. So if we see the university students, there are more amount of students who are crossing this threshold. Similarly, if you go for something like uh, occupational status, we can see that school students are pretty much in the good line. The university students are Most of the university students are crossing the threshold, and where most of the salaried workers are not crossing the threshold or are in a good state. So now if I put this CSP over here and do the prediction, so we can see the predicted values coming out of the software, as we have the generalized linear model, deep learning model, decision tree, random forest, and support vector machines, and gradient boosted trees. So I like to show one of the examples. Like if you see in the deep learning model, and if you go to the simulator, we have the provision to put things like if we can toggle between the ages, and we can see how the age itself is playing a role in increasing or decreasing the prediction value. We can see how the gender is playing a role. We can see how the relationship status is playing a role. Apart from that, we are also having something like optimize all the values. If you want to maximize or minimize and see which kind of parameters are making these values less and high. So let me walk through one of the simulators over here. So this gives us provision to put inputs like the age, gender, and see how this prediction value is increasing. So let me remind you, this prediction value, the higher the prediction value is, the higher the chance that the social media is creating health related issues. So we can see as the age is increasing, this factor is decreasing. Also in the teen age area, we can see this is spiking too much. Now we can change them to like we can change the gender, we can change all kind of, we can toggle between all kind of this We can see how Pinterest is having impact on this thing, and we can also see the impact over here, which kind of, like in this thing, the kind of organization that a person is affiliated to is having a higher impact than the something like Reddit or Snapchat. So so we can toggle between the inputs and see how this input is affecting the output. So this was all about the Rapid Manner Studio. So let me walk through this PPT for once. So these are the all 12 major questions which we're trying to answer, and the higher the answer of these questions are, the chances are higher that the person is probably suffering from some kind of health issues because of social media. So this was the design layout. So these are the results. And these are the 6 different bins which were created by the discretization operator. And this is the polynomial regression equation, which if we solve, and if we solve this equation, we can find the prediction value. So these were some of the results from the naive pairs, and this is a snippet from the decision tree, and this is the auto model, the kind of decisions you're getting from the auto model. Thank you for listening to this conversation. Have a good day.